And there they went and won. It's like, great.
Now she's sad about not watching it.
Yeah. She'll watch the next one, and they'll probably lose.
No, they're going to play Sweden or South Korea. They should win that. If we beat Germany.
Thank you for saying that.
What?
Thank you for saying that as well. Now I am not going to watch the replay.
What?
My team lost.
Spoiler.
Thank you.
Thanks, Madit.
I'm bad.
Like,
Okay.
I watch the replay tonight, and then he goes and says,
Okay, we're streaming live to Richmond. Let's get back into it. And I promised you we're going to cover PostgreSQL and MySQL. So the nice thing is, all the SQL stuff that you're just like, hold on, Ellie, I still want to learn some more SQL. No problem, because SQL is the language that they use over in those other platforms too. Not a whole lot new. So we can use whatever database platform we want as long as it's relational and it's going to speak the same language, SQL. But Harper mentioned that there's this little database diagrams thing. And sometimes when you're looking at a database that you didn't build, of course, if you just built your festival site for Woodstock 2019, you know the table relationships, you know how it all fits together. You don't really, you built it on a piece of paper. You know what it looks like. But what happens if you have somebody else's database? Well, it helps sometimes to go say, new database diagram. And I'm just going to say, give me all the tables. And throw it into this database diagram. And sometimes it's helpful to see, show me what you would have drawn on paper for real. So see these lines? See the little infinity symbol? That's the little 2. That means many. And it's hard to see because I've got my resolution up to like 200 pixels by 50 pixels. But you see that staff. And remember, we're writing queries against this just yesterday. If you ever have a question about how do I get from this table to that table, what joins do I have to do? And that's often what you're thinking about when you're doing SQL.
Harper wants you to zoom in.
Zoom like that?
I don't know. He said. Right click zoom.
Right click what?
Zoom.
What do y'all want to see? Fit. It's going to be really small. So the nice thing is with database diagrams, it gives you what it thinks is going to be pretty. Sometimes it's not going to be visible if it's pretty, so you can move things around as you like and try to get it to fit better. So let me do that. Notice, what's this thing over here? That's a table that's not connected to anything else. It's not necessarily wrong. So this is the entire database mapped out. Now, if I wanted to make this more readable, if I only care about 3 or 4 tables, I can remove some of these. Like, okay, I really don't care about, let's say we only care about these over here, because that's the query we're writing. So let me get rid of some of these other ones. It's not often you want to see the entire database mapped out because the drawing gets big quickly. So let's do something that's readable and say we're only writing a query for that, and even that's a little bit big. One thing that you need to be careful of when you're doing the database designer is this is also capable of making changes to your database structure. So this is wired into SQL Server Management Studio. If you make a change, like if you delete a relationship, it might drop the foreign key. If you change a column name in here or change the data type, right? Watch this. Right click, say, I rarely use the UI. So table view, show me the standard. See how that looks? I can zoom in. This is almost exactly what you saw when you created the table. This is like right-click on table and choose design. It's the same type of thing. It also has the same power. So if I were to add a column here,
build your whole database, right?
You could build your database this way too. And if I click Save, and it says, oh, you're about to make a change. Do you want to do that? It's like, okay, you could say, no, I don't really want to do it. If I click yes, what did it do? I'm going to go back over here and let's look at the film actor table. I just added a column there. Film actor, columns, refresh. I created a new column. So it's a nice feature. Just know that you're dealing with a powerful tool here, and it's going to make changes if you make changes. Right-click, table view, column names. So this, as Harper was pointing out, and let me know if somebody in Richmond speaks up and says they want to see something else. You know what these are. The little key means the one. The two little circles means many. And if you want to see the details, click on it, right-click, properties, and this will tell you tables and columns. It's like, okay, what have we got here? We got a foreign key table, we got a primary key table. Which column we joining? It's the category ID. Okay? So with this is exactly like what you draw on paper. This connects the tables, except this is real. This is a database that SQL Server is reverse engineering the foreign keys and primary keys that you've defined, saying this is what you meant.
Why are there two? I thought that you could only have one primary key per table.
You can only have one primary key per table. That's true.
They were showing two, but now changed it.
I'm not sure why it was drawing two there.
That happened on mine as well.
Yeah.
Showing two till I moved it.
Yeah, he was confused there for a second. I'm not sure what was going on there.
Which one is the primary?
Primary key is the one that has the key on that side. So in this relationship between film category and film, it's saying the primary key in that relationship is going to be on the film table, film ID, and the film category table has the foreign key. That's the child table. That has the two circles. Any questions about this? It's just another visualization of this is how your database relationships work. And if you want to save a little subset, this is how those tables are related. When you save here, if you didn't make any changes, all you're doing is saving a picture of the relationships. And this is nice if you ever want to show somebody else, like another developer or, say, the end user or somebody who can understand database relationships and it's like, oh, is this right? You can save this, or you can, here, with snippet, it's like, let me take a little picture of that. Picture is worth 1,000 words. That's a picture now. I can paste that into an email and show people what I'm doing. Share the information. Okay, so we've talked a lot about SQL. We've talked about relationships. Let me see what else I wanted to make sure that we covered this morning. Okay, functions. Functions, these are going to be platform specific, which means that in SQL Server, what's the dialect of SQL Server SQL? What's it called?
Transactional.
Transact SQL, T-SQL. So in Transact SQL, they have these functions at your disposal. Let's go through them, and let me show you. SQL Server is immediate gratification. Remember that. So if I don't know what these functions do, open a query window, any database. The nice thing about functions is you can use them in isolation and see how they work. So let's figure out how this substring thing works. These are string functions that are predefined for you. Substring, char index, len, left, right. So I'm going to open up a new window down here, and let's do select substring. Let's see how this thing works. What do you know? We have IntelliSense. So a substring is going to work on a string expression, which could be a column that is a string. I'm just going to hard code a string there. It says starting position. I wonder if it's 1 or 0 based, like index of the string. Which character are we talking about? So let's do 2. And let's see which character it gives us. And it says, how many characters do you want from there? I want to have 1 character. How do you run a SQL statement? F5. And look what it gave us. It gave us B. Who can explain what that does?
This is selecting the second character in the string.
It's-
ABC.
Yep, so A, B, C, we're saying give me the second character. How many characters do you want? 1. What if I change this to 2? What was your question? B, C. If I said 1 for 2, what's going to be the result? A, B. Now, that's all it takes to understand what a function is. If you don't know what it is, you have IntelliSense. If you want to play with it and figure out how to use it, just play with it like that. You don't have to write a huge complex query to figure out what things are. Let's go through and let's do another one. There's an easy one called len. What do you think len does? Length. Okay? What's that going to give us?
5'2".
6.
5'2".
Not 5'2". 7. It just counts the number of characters. That's all it does.
Does this ever start the index at 0, or does it always start at 1?
The question is, do you ever have to think about the index starting at 0? In Transact SQL, they like to start at 1. And that's kind of a norm, a tradition, a standard. I wouldn't expect it. You have to look at each function. But in Transact SQL, it starts at 1. In C#, they usually start at 0. So you just have to know the context. So substring char index. Let's do that one. So we don't know what we're going to pass. Let's see. The search expression, expression to be searched. What are we looking at here? You remember from JavaScript functions, right? What do you pass to functions? What's it called? Parameters. This is just parameters to a function. So we're saying search expression is, this is what we're going to be searching for. So let's search for D. We're searching for inside of that string. And you can optionally say, I want to start only after the third character. We don't really care about that. We just want to say, find me D in that string. And let's see if that's right. 1, 2, 3, 4, 5, 6, 7. The 7th character is D.
Why did you know that the third parameter was optional?
Why did I know? How did I know that the third parameter is optional? That, I believe, is just experience. Let's see. Does it tell you? No. Sometimes, see this documentation right here, it should have that start location as in italic or in square brackets or something to tell us, but unfortunately the documentation is a little bit poor here. I just had to know. Now if I said, I want to start at character 8, what's going to come back?
No.
Null or 0 in this case. This is how you learn to play with the functions. Once you learn how to play with it, let's use one of these in a real query. We're in the context of the SQL test database, and we have that customer table, right? Let's do a little diagnostic query. And it's all well and good to understand how things work, but unless you can really use it in a query, it's not going to do you a whole lot of good. So how are we, what's a string field here? We got first name, right? First name. Now, when I'm doing testing out a function, I like to have, give me the whole thing, and then right beside it, let me have another column to see what I get if I apply my function. So let's put these things together. Let's say, let's find the k, if there is one, and give me the rest of the string. So the rest of the string, that means right. So select right. Let's see what that one does. Expression ints. So this horrible documentation, but it's okay. So let's play with this. Ricky. I want to start at character 3. That means give me everything starting at character 3 to the right. What do you think left does? Yeah. left, right. So let me put that back up there because I'll paste that now. So first name, and say we want to say, let's find the K in the first name column and give me everything after the K. Let's put these two together. So how do we find the K first? Okay, so this worked up there for Kelly Dixon, looking for a D. Let's find a K, and we don't want to say Kelly Dixon. We want to say what here? Okay, and you can do this iteratively. You can just like, let's run that and let's see what happens. Okay. It's like, okay, there aren't any K's in Nicholas or Queen, so zeros come back. Now, how do we nest them? You pass the result of this into another function. So I'm going to say, give me everything to the right of that. Right? And it takes two parameters. First one is going to be first name. Second is to be, where do I start? So this is going to give us everything after the K. Or,
Yeah, Kim is just the letter F.
Rick. So right, first name. That's not right. So char index, I bet you I got the parameters in the wrong order. Returns var char. So it says right, first name, char index of Well, let's see what's going on here. Let's run those separately again. So I say, that's going to give me character 4, R-I-C-K. And then we say, give me first name. Oh, you know what it's doing? We're not looking for that. That second parameter says how many characters you want from the right. So we want, it's not going to make sense here because it's counting from the left. So let's do left. In order to do right, we'll do that in a second, but I'll show you. So it says, give me, wherever you found the K, give me the leftmost. Now if we want to invert that, we want to say, give me the rightmost. This is where it gets, you know, you got to nest them. So if I want to say right, how many characters? Len of whatever it is, minus. Let's walk that through. I didn't mean to give you a complex example like this, but it happened. So let's break this down. What's the rule in math? What's the rule in programming? You do the innermost parens first. So let's find the innermost parens. In this case, it's going to be the things we're passing to this parameter. So that right there, we're passing into the right function. And the right function takes the string, and it says, how many characters on the right do you want to get? Well, if we just said char index, that counts from the left. So we can actually see it's going to be 4, R-I-C-K. So the fourth character is K. If we say give us the right 4, it's going to give us I-C-K-Y. That's not what we want. What we want is, we want the length of the string, which is 5. Let's actually put that up here. You can, you know, we're just playing. This is diagnostics. This is how you figure out how to use functions. So the length is 5. Let's do some math. So that's 5. That's going to be 4. That's going to resolve, what's 5 minus 4? 1. So it says, give me the right of first name for one character, which is exactly what we get there.
Harper wants you to do initials.
Thank you, Harper. Actually, that's pretty straightforward. Let's. I'm going to leave that because some people might want to take a look at that later. Let's get the initials. In English, what are initials? So the first letter and the first and last, and we're going to put together in one virtual column. How do we say it? We know how to do that. So we could do char index. Once again, there are multiple different paths to success. We could do char index. Let's do it 2 different ways. So char index of first name 1 for 1. So I'm going to give me starting at the first index, go for one character as first name initial. And we do the same exact thing for last name initial. And get rid of that. That's not going to work. Well, we haven't actually done anything. Char index gives us the index. So really what we want, it's not char index here. What is it? Substring. I used the wrong function. So substring, 1 for 1, R and B. Now we also know another way. Let's do that same thing using a different function. How do you say, give me the leftmost character? Left, and you just say, how many do you want? 1. Same thing. Now, how do we make it into a nice, pretty column that users are going to look at, rather than 2 separate columns? We just concatenate. How do you concatenate in SQL Server? I showed you 2 different ways. You can say concat. And let's, do you want a space in between? Probably not in this case. You want a what?
Period.
A period. Yeah, how do we put a period? Let's, as initials. How do you put a period in there?
A space. With quotes.
It probably has to have a period at the end too, right? This makes sense. There we go. So the point of this is how you figure out what the functions are and how to use them. You don't have to drop it directly into your complex join of 10 tables. Play with it first, understand what it does, and then drop it into your query. Okay. So dates. Oh, by the way, there is not a function, but it's a keyword. How useful would it be to be able to do an if-else statement in your query sometimes? It's very useful. You want to be able to say, sometimes I want to show this, sometimes I want to show that. That's what the case statement is for. And case is a standard SQL keyword. So let's say if your name is shorter than 4, I want to say your name is too short. Otherwise, I'll show the first name. I'll leave that up there. New query. Select. Let's walk through this. We're going to look at the first name. So how do we talk about the first name? Select first name. What table is that in? Customer. So let's feel successful. There we go. Now, what we want to do is, if the first name length is less than or equal to 4, we want to say your name's too short. Don't even report the first name. But if it is at least 4, then we're going to actually show the first name.
So you said it's a case, not if else? Well, I know that's the same.
So let's look at, we'll leave that alone, but case, yeah. And it's like an if else.
Between the select and the from.
When? How do we figure out if it's, how do we look at the length of the string? Len, a first name. Now, what are we deciding on? If it's greater than or equal to 4, right? Greater than or equal to 4. Then what are we going to do? If it's greater than or equal to 4, what do we want? Just show the first name, right? First name. Else, what are we going to do if it's less than 4?
Say your name is too short.
Sorry.
If you don't want something to show, though, if you just don't want
Just
your
end.
results to come back, or
How do you say absence of a value?
No.
No.
Else no.
And let's give it a, right here, it's going to give us the result, but it's not going to have a column name. Let's give it a column name. How do we say that? It's a column alias.
As
As what? What do you want to call it?
Loser.
Calculated first name. Kirsty's got a mean streak to her. There we go. So that is a simple if-else. You can use this, obviously not for looking at first name length, but you can use it for anything. That's why I'm showing you the case statement. If you want to conditionally have, I'm going to calculate and decide what to show them for this row, for this value, you can do it like that.
I've seen case statements where it'll be case and then like the name of a table and then when. Or it'll have something in between the case and when.
Okay, Scott's pointing out, you know, I've seen another flavor of the case statement. And you're absolutely right. There are two. That's the good news. So there are only two, and this is one. In this one, the structure is this. You say case, you don't put anything up here, and you say when, and then you have a conditional. It's like an if, else, if, else, if, else. And the last one, if you want, you can say else, whatever, anything else. Another way is, that's flavor one, case first name. So what we're doing here is look at the value of that and then find the one that matches. So in this case, we're going to say Ricky Turn blue, what does that mean? It's a keyword. We really want to use it, so we're going to put in square brackets. So, let me separate that a little bit. What is this going to do? It's looking at the value of first name for each row as it goes through, and it shows you a different message depending on what that first value is. This one is less frequently used because you have to match exactly what you're looking for up here. Any questions about the case statement? It's pretty straightforward. It's a very powerful tool, and you're going to reach for it pretty often. You're going to use it for, you don't have to say just a value here. Could we also say case when subquery exists? So everybody has at least one order. So case can be as complex as you want. You can throw a little subquery in there, do whatever you want. You see how these things build on each other, and that's where the complexity, that's where database developers spend their time. It's not in simple select from table. It's not even from select from interjoin these three tables. It's from the user asked me this complex business question, and I've got to use my SQL talent to figure out the answer. And case is going to be invaluable to you in figuring those questions out. Richmond, anything else? Let's see. Okay. Dates, there are a bunch of functions for dates too. We were talking about this morning on the way in, and Harper said, you know, I only ever use one or two ever. The rest are so seldomly used that it's not really worth talking about. So I'm gonna paste all this code, so don't worry about copying it down. Let's play with dates. How do you figure out a function? How do you figure out how to use? I just showed you with strings. Select, get date, and let's say get UTC date. What do those things do? Get date says, whatever the system time is on this server, and I happen to be in Eastern Standard Time, show me the date value. This is UTC date, universal, so it's Greenwich Mean Time. When you get into the application here, we're going to explain why almost all systems, if they're written properly, use UTC date, because systems are global. We don't care just about Eastern Standard Time. If you're in Singapore, we need to know when this occurred worldwide. So we need to have a baseline date and then translate that to, oh, you're in Singapore, let me convert that for you so it's local time for you. So why did we start with those? Because date functions take a date as input, and these give you the current date time on the system. Date part. This is going to be one of your favorites, I'm sure. You know, it's one thing to speak technology, but we have to actually talk with people who speak English. So date part, interval, let's see, weekday, I think that's one. Nope. Let's do this first. Okay, obviously I don't use this very often. I know it is. It doesn't want the string. Let's see, date part, date name is what we want. So that's going to be day of week 3. So Sunday, Monday, Tuesday. Let's say month. I think that's month and not minute. Yep, month is 6. Year, 2018. So this is by the way, up here, I glossed that over right here. I've got a string, but I wanted to put a single quote in there. The way you say that in SQL is just put 2 single quotes right next to each other. And you'll say, oh, you really want the single quote. The one I was thinking about is date name. Date name, give me the day of week or the month. June. Now we're speaking English. And it's not just English. If you're on a system that their current culture setting in Windows or the operating system is Spanish, it'll be junio. So it'll look at the local system culture settings. So date name, month, day of week, Tuesday. So pretty powerful. You can get with one date value, you can translate it to display however you want. Formats. Get dates. And this is really horrible documentation. Look at that. Tiny int and param3. Thanks somebody for taking 10 minutes to write the documentation. I got that wrong. What do you think it is? Lowercase, probably. So with that, you can say, I want to have a date format that looks like this or that. And let's do month, June 19th. See what we're doing there? You can get out whatever you want. just store your data types as date, date, times, and it'll figure it out. Oh, that's a date time. So if we want the hour, minute, second. Hour, minute, second. Lots of power here. Coalesce, is null, cast and convert. You've seen now that sometimes you have a date and you want to make it a string, or you have an integer, you want to make it a string. In SQL, if you do plus sign or concatenate, it's not like JavaScript. It's not forgiving. It's not going to just throw it together as a string. You have to tell it you want a string if you want a string. So if I do this, fail, because I'm putting a number together with a string, and SQL doesn't like that. It's got to be the same type to concatenate. So how do you do that? You convert the number to a string. You have to tell it. It's just a function, and then it's going to be happy. Another way to say that is cast. The cross-platform way of doing this, which one do you think is cross-platform? You had a 50-50 chance. You guessed wrong. Cast is cross-platform. So if you want to learn syntax that's going to work on MySQL, Oracle, whatever, cast. If you want to concatenate across platform, how do you say it? Concat, C-O-N-C-A-T. The plus sign is specific to Transact SQL. In Oracle, if you concatenate, I showed it to you like a minute yesterday. It's bar bar. I'm not going to spend a whole lot of time on this. I'm just showing you. Here are some cool tricks that you can use. Now, oftentimes you have nulls in your database, and you want to say, we don't have any nulls in this one. You know, I'm going to, we have our little test database. Don't try to keep up with me just for a second. What I'm going to do is I'm going to change this customer so that first name is optional. Right now it says not null. Anybody know the DDL for changing that column definition? You're about to. You're redefining it. Now if I refresh that, I made it nullable. Why did I do that? Because I'm going to take out Maduro's first name. I'm doing this for a reason. So now if I look at my customer table, I've got a null. I'm doing that to show you this little feature. What's going to happen with Maduro's value there?
Just be listed as euro.
You would think it's going to give you Maduro, but it's not. What's the other option that might happen?
No.
It's going to give you null. Null trumps whatever you concatenate to it. Okay? That's not very pretty, so how do you say, if you got a null, forgive them. We'll put a little placeholder or a space in there.
Null as.
You say, if it's null, this is how you read this in English. Is null says, if it is null, put a space there. If it's not null, use whatever the value is. There's another way to say that. There are two other ways to say that. The cross-platform way is not is null. That's Transact SQL specific. You say coalesce. Does exactly the same thing. With the upside that if you have 3 or more values, it'll take the first one that's not null. It'll go through the whole list. Give me the first one that's not null. The other way, you know the other way. How do we say an if-else statement in line here?
Case.
Case.
When, first name,
Common mistake. You can't say equal with no.
Right, it's no.
Yeah, it's that crazy is.
Then
Make the string, whatever.
And if it's not null, what do we want to do?
Else.
this is where you want to.
First name, last name?
Yeah, you
Just first name.
Oh.
Because we have the last name over here.
No.
Okay? So it's complaining that I forgot my comma there. Exactly the same thing. Just 3 different ways to write it. So I'm teaching you there's no one right way. It's just fine. Be creative. That's what null and coalesce do. Question?
So that end.
It's 12 o'clock, so make it quick.
Okay, the end of the first hand, it just completes the case statement, and we'll probably keep running the rest of it, right? It doesn't stop it from.
The question was, the end over here, what is going on with that? The end is part of the case statement.
Okay.
So the way you read that is case, and it's doing whatever you're going to do. End means the end of that case. And then you can do whatever else you're going to normally do. I'm going to paste this in there. And do go through the restore procedures. I gave you the sample database restore document. It's in Slack. Restore that right around 1 p.m. If you're not able to restore it, we're going to go through it in class at 1. But have a good lunch. We'll talk to you at 1.